Now let us see few real life example where we will be using the stack data structure. We can use the stack data structure to reverse a word or a string. How we will use that? Let us see that. One of the example of using the data structure to reverse a word or a string is like this. So if you want to reverse the word called big, so what you will do is that you will create a data structure and you will start pushing from the beginning. First you will push B here, then I will push I like this, then I will push G. So now this data structure will have first character or object as B, next character as I, next character as G. So first B, then I, then G. Now when I want to pop out, what I will do is I will pop G, so it will write G like this. When I pop out, I will start writing. Then it will pop out I, so it will write GI. Then it will pop out B and it will write B. So what I am going to do is that I will print out as the pop happens. At the push, I will not do anything, I will just keep pushing. At the time popping out, I will keep writing the character as it pops out. So you see this big has become gib. This is called how to reverse a word or a string using a stack data structure. Another example of a stack is the Java virtual machine stack itself. In Java, JVM uses a Java method stack, and the Java method stack is basically a private stack for each running Java program or thread. For each thread, there is a separate stack which is used for each running Java program or thread. It is used to keep track of important information on methods which include local variables, program counters and parameters. So what happens is that, let us assume this main function 1 call function 1, function 1 call function 2. So this is the way, this is the main function, okay. So let us assume it call function 1, function 1 calls function 2, function 2 might call something else. Now this flow of execution of all the methods are stored on a stack which is either called a method call stack or the thread stack. It is same thing. The name, whether you call it a Java method stack or Java thread stack, it is pretty much the same thing. So what it happens is that when it enters one method, it stores the details of that method, and whatever local variables have the value there, I equals to 5, it will store I equals to 5. Now when it goes and call this one, function 1, it creates another stack called function 1 with the name called function 1, and whatever is the local variable there, it will store there. Now if function 1 call function 2, then it will store another stack. These are called stack frame. So this is basically a stack. These are individually called stack frame, and the whole thing is called stack. So Java method stack happens. When this function 2 completes, it goes back to here and then it works on the remaining part of it. So that is the way the Java method stack works. Its element is called frame, which is a descriptor of one of active invocation of the method. So to explain you very briefly, stack is used in JVM as well. Recursion uses the stack, and recursion also uses the same method stack, and it is just a special case of previous use case. So it is not very different, but whenever you think about a recursion, you can think that recursion is using a stack data structure. So it is not very special case, but you can say that it is just a special case of previous use case. Okay. Another important part of this one of stack is arithmetic evaluation. It can be also done using stack. So how do you do the arithmetic evaluation? So let us assume that I have a requirement to do this. 7 plus 8 multiplied by 6 minus 4 divided by 5. So what I will do is that I will just take whatever is inside the first closed bracket, that is 7 plus 8. Okay. Once we take 7 plus 8, first we will take 7 plus 8. Okay. So what we will do is that we will first push 7 and we will create two stack. Okay. So this one is called stack 1 and this one is called stack 2. So we will create two stack. Okay. Stack 1 and stack 2. Now in stack 1, this 7 plus 8, which is inside the first closing bracket, first complete expression without any other bracket, we will take 7 plus 8, we will evaluate first, and then what we will do is that we will replace this with the end result. So 7, all the numbers will push it here, all the operation will push it here. So first we push 7, that is here, then comes plus, so 7 got pushed here, then plus got pushed here, and then 8 got pushed here. Okay. So 7 plus 8 is done like this. Once it is done, the result of these two is here, 15. Now we have a result called 7 plus 8 is 15, and this is disappeared. Now after that, what we do? After that there is 15 star in bracket 6 minus 4. So what we do is that we put 15 here, and then we do star, and then we do 6, and then we do minus, and then we do 4. So this is the way the sequence happens. Now first what we do is that we take the top two operation in this stack and take this one here, and whatever is the result of this and these two, we put it here. So 6 minus 4 is 2 here and 15, and then we are left with a star, and then 15 and 2 is used with this one, and then we are left with 30. Once we reach here, then we take care of this division and 5. So what we do here, we put the division here and then 5 here, and then we get 6. So this is the result of arithmetic evaluation using stack.